Okay, there we go. So as we left off class the other day, we started number 2A. I set us up with that, but we didn't finish it, and I left it blank. I completely erased it because I want to go over it all again. I want to do number 2A all over in case you missed or just weren't paying attention or whatever, and then we're going to finish that one today. So when we are doing problems that say partial fraction decomposition, we're breaking apart the fraction in order to solve. And I start by factoring the bottom. So I've got the bottom x squared minus 2x minus 15. So that becomes multiplies by 15, adds by 2, so x minus 5, x plus 3. The top stays the same, 5x minus 1, that's good. From there, I told you that is equal to two fractions being added together. It's equal to something over x minus 5 and then something over x plus 3. We don't know what those somethings are, so we literally put in a1 and a2. I guess technically you could use y and z, but sometimes those many little variables get all messed up in my head, so I'd rather use these like capital A1s and A2s because that looks very different than what we're doing. So I'm starting by separating it here. And then in order to start getting towards a matrix, because again, we're in our matrix chapter, so our end goal is a matrix, we're going to clear the denominator. Back in chapter 2, we did a ton of problems like this. And when you clear the denominator, I just take whatever's on this left side because that's the biggest denominator, and we're going to multiply that by everything. So I'm going to multiply everything by x minus 5 and x plus 3. Now, so I'm going to distribute that to everything. When I distribute it to the left side, the entire denominator goes away because it has both x minus 5 and x plus 3. So all I'm left with on the left side is 5x minus 1. Next, I'm going to multiply it by the a1 term. So the x minus 5 cancels, and so I'm just going to have a1 times x plus 3. And then my last term, I have my x plus 3's cancel, so I'm left with just a2 times x minus 5. From there, I distribute everything, and I want to get all my x's together and all my constants together. So I'm going to distribute my a1 into this parentheses and my a2 into this parentheses. So I've got 5x minus 1. I think I wrote it a little bit differently yesterday or last class. I think I wrote like a1x, but that looks a little confusing to me. It does not matter. It's multiplication, it's commutative, it doesn't matter. But today I'm going to write the thing in front and the a1 and the a2's in the back. Again, doesn't matter. X times a1 plus 3 times a1, and then x times a2 minus 5 times a2. Again, if you were keeping up with notes the other day, you have all of this. You're just reading along with me. The next thing I wanted to do was get all my x's together. So I've got x times a1 and x times a2. I want them together because I'm going to separate out with like my x's as an equation and my constants as an equation. So I've got 5x minus 1 equals x times a1 plus x times a2. Those are all like terms that are in the same spot. And then I'm going to put my constants in the same spot, so the numbers without x's. So 3a1 and negative 5a2 are going to go in the back with next to each other. I'm almost ready to separate into my equations, but I don't want to carry x with me. So I want all of my like coefficients, or I want to just factor x out of everything in my green highlighted. I can't factor anything out of my constant. So I'm just going to leave that as is. The only thing I'm going to change is instead of writing x times a1 plus x times a2, I'm going to factor out the x and just have a1 plus a2. I'm sorry. It's like everyone's emailing me during lunch. I can't turn it off though, or else I can't hear you guys. So I'm so sorry you're listening to that. So the only thing I changed was this green highlighted. The pink's going to stay the same. And that just makes it easy when I go rewrite my equations. The highlighting might seem silly, but I'm going to keep it up. I'm going to keep my constants highlighted in this pink, and I'm going to keep my x's highlighted in the green. Okay. And so now what we're going to do is we're going to come over here and we're going to write this last statement as two different equations. So the green thing is going to be an equation and the pink one's going to be an equation. I'm going to lose my x's when I carry the green part over because I've got 5 times x, or 5 times something, equals a1 plus a2 times something. Whatever that something is, the 5 and the a1 plus a2 must be equal to each other. So whatever I'm multiplying by, whatever x is, a1 plus a2 has to be 5 because their coefficients must be the same. So I'm going to write 5 equals a1 plus a2. And then I'm going to do the same thing with the pink. I'm going to write -1 equals 3a1 minus 5a2. I had nothing to lose on that one, though, because there was no x's there. So I don't have to cancel anything out. I'm just literally taking my constants over and making a new equation. So -1 equals 3a1 minus 5a2. Did I do that right? Okay, yeah. All right. Okay, after this, we put it in a matrix form. You can technically do REF at this point. You can do RREF. You can do solve just using systems instead of a matrix. That's fine. I prefer inverse method. I think that's the most foolproof and it's, I think, the easiest to think about. So I'm going to write this in terms of an inverse matrix. So I've got my solutions on the left side. I know it's written funny, but that's okay. I'm going to have my coefficient matrix, and then I'm going to have my variable matrix. We don't do a ton of matrices by hand, but if we did, the best way would always to have a variable matrix of like X and Y, or in this case, A1 and A2. My coefficient matrix just comes from the coefficients above. So I have 1A1 plus 1A2, so my first row is 1, 1. In my second row, I've got 3A1 minus 5A2, so it goes 3, negative 5. Now, again, I said I was going to solve using inverse method. I essentially have my B matrix equals my A times X. When we do inverse, we say X equals A to the negative first times B. So if I can take my A matrix, enter that in the calculator, do that to the negative first times my B matrix in the calculator, then I'm going to find out what A1 and A2 should be equal to. So again, I wrote this in the matrix just so I could go into my calculator and enter them. So I'm going to, I guess I've got room down here. So I'm going to physically type A to the negative first B in my calculator. Obviously, after I make sure A matches whatever my A matrix is and B matches my B matrix. And then my answer is going to tell me what is my value for A1 and A2. And then I can plug those in above. So whatever I get out should be a 2-by-1 matrix that is my answer for what value goes for A1, what value goes for A2. Anybody have any questions yet? All right, let's throw it in my calculator. I have to adjust because we did some changing of my matrices last period. So make sure you're doing a 2-by-2, and my A matrix is 1, 1, 3, negative 5. Cool. And then my B matrix is a 2-by-1, and it goes 5, negative 1. I don't remember if I preached to your class, but make sure you're really careful on entering your matrices so that it's the same answer and it's exactly what you see. If you miss a negative or mistype a number, you're going to get the wrong answer. Once I have both my matrices entered, again, I'm going to go write A to the negative first times B in the calculator. And my answer is just a little 2-by-1, which is 3, 2. What that tells me is instead of writing A1 and A2, I could have written 3 over x minus 5 plus 2 over x plus 3. And that's the same thing as the fraction we started with. So that's my answer. Anybody questions yet? The next one's the same method. It's just a little longer because there are 3 parts. So I'm about ready to start that. Does anyone need me to stay here for a second? No? Okay. All right. Let's go down here. I got to factor this out first to kind of see what's going on. And I'm going to get rid of my calculator because I don't need it yet. All right, so I factor this down. I'm going to get, I can take an x out of everything. So I get x squared minus 4x plus 4. Now I can factor the inside. Multiplies before, adds be negative 4. Okay, that's going to be x minus 2 and x minus 2. All right, awesome. Okay, so this is my new denominator. So I've got negative x squared plus 2x plus 4. All of that is over x, x minus 2, x minus 2. I'm going to separate it into 3 parts. Now, this didn't feel like common sense to me, so I'm going to explain it kind of slowly. My first factor is x, so I'm going to write a1 over x. Okay, that makes sense to me. The next one is going to be x minus 2, so I'm going to write a2 over x minus 2. Now, I wanted the third one to just be x minus 2, but we're going to write it as x minus 2 squared. The reason we do that is because when we cancel out the denominator, if we just left this as a negative x minus 2, it would treat these as the same terms, and they should be different terms because I have 2 of these x minus 2s. So in order to count them as 2 separate ones, I have one x minus 2 like normal, and I've got another one that is squared. So again, doesn't necessarily make the most sense of what we might think, but whenever you have a double factor, one of them's normal and then the other one is squared. Now, what I'll tell you later, I guess I can just preface now, what I told the other class is like, this is going to take us a while and it's got a lot more steps. If I were to put one on the quiz or test, it would be one that looked more like A, because it's a little bit simpler. It's a 2x2, a lot less room for error. This 3x3 is a little long, but I need to show you the hardest stuff so that everything else seems easier. So I'm going to carry on with this one. Know that this is squared, even though it doesn't necessarily make sense, but that is what we do to make up for what we're about to do when we cancel the denominators. So when I cancel the denominators, I have to multiply by x, x minus 2, x minus 2 from everything. So I have to multiply all of this by x times x minus 2 times x minus 2. When I multiply by the left-hand side, the whole denominator cancels and I'm just left with the numerator. Negative x squared plus 2x plus 4. When I multiply it by my first term, the x is what cancels out. So I'm going to do a1 times x minus 2 times x minus 2. When I do the second term, I just have one x minus 2. So I'm going to cancel that out, and I'm left with a2 times x minus 2. I only get rid of one of the x minus 2s. And then the last one has an x minus 2 squared. So I get rid of both of the x minus 2s, and it's just going to be a3 times x times x. All right, now we're going to distribute. We're going to get all the like things together. Again, this is kind of the algebra step, so we can set up and then do our matrix momentarily. I'm really just going to ignore the left side and I'm only going to focus on the right side, distributing everything through and combining like terms. I think it's going to be easier to distribute or FOIL the x minus 2's and the x to the x minus 2, and then I'll multiply a1 times everything. So I've got a1 times x squared minus 4x plus 4, and then a2 times x squared minus 2x plus a3x. I now get to distribute my a1 and my a2s to everything, and I'm going to put them last. So I'm going to put all the variables and all the coefficients before them. So I'm going to say x squared times a1 minus 4x times a1 plus 4 times a1. And then I've got x squared times a2 minus 2x times a2. And then I'm just rearranging a3x to be x times a3, just because I think that's simpler in my head. There's a lot of superscripts and subscripts, so be super careful with what you're writing. And then the last thing, or not the last thing, but the second to last thing I'm going to do is put all my x squares together, put all my x's together, and all my constants together. So let's see, here's an x squared, here's an x squared. So they go together. X squared a1 plus x squared a2. Then I'm going to do all my x's together. So I've got negative 4x a1, negative 2x a2, and then x a3. Don't forget about that guy. I almost forgot about him last hour. Minus 4x a1 minus 2x a2 plus x a3. And then last is just going to be the constant, which is 4a1. The last step before I write my equations out is to factor out the x squared and the x from all of these, so I don't have to carry that through. I've got one more step and then I'll bring my left side down with me. I just didn't have to deal with them yet. So I factor in x squared out of x squared a1 and x squared a2, so I get a1 plus a2 times x squared. I factor in x out of all of the pink ones, so I get negative 4a1 minus 2a2 plus a3 times x. And then I have nothing to factor out of the orange term, so I just leave that as 4a1. At the same step, I'm going to bring down this left-hand column that I've kind of been ignoring this whole time, negative x squared plus 2x plus 4. And I know the highlighters might seem silly, but I am going to keep everything together. So as I highlight it, I'm going to write a new equation. So my x squares, I've got negative 1x squared. Again, you lose your x's, your x squares when we write our new equation. I'll say negative 1 equals a1 plus a2. Then I'm going to do my x's. Again, I'll lose my x's. But I'm going to do 2 times negative 4a1 minus 2a2 plus a3. These are x's. And then last, I'm going to do my constant, which is going to be 4 equals 4a1. Anybody questions yet? All right, now I write these into an equation. Again, you can do other methods. If you want to talk about what other methods you could use to solve this, let me know. I just think inverse is the easiest one. So my solution matrix is -1, 4, sorry, -1, 2, 4. My coefficient matrix, whenever you have a blank, so like I don't have an A3 in the first equation, and I don't have an A2 or an A3 in the third one, you just put zeros in. So I'm gonna do 1, 1, 0. I'm gonna do -4, -2, 1, and I'm gonna do 4, 0, 0. And then last, my variable matrices, A1, A2, A3. I don't physically have to write this step out, but I'm going to take my A matrix and my B matrix and do A to the -1 times B, and that's going to tell me what my answers are. I'll have A1, A2, A3, and when I plug it in, I'm going to get 3 little answers. It's so much space. I don't know why I wrote that like literally in the corner. There we go. So yeah, I just got to go plug in matrix A and matrix B and just press my inverse method. Anybody questions yet before I go to my calculator? Inverse. No? Okay. I always change matrix A and B for whatever reason. I need to make sure though I'm doing a 3 by 3 now. So I've got 1, 1, 0. I've got -4, -2, 1, 0. Or sorry, 1, and then 4 and 0 and 0. 1, 1, 0, -4, -2, -1. Okay. That matches. Now I gotta do B. And now it's a 3 by 1. Okay. And so that's -1, 2, 4. Again, always double check, especially when we're plugging in for matrices. It's such a silly thing to lose points on because I like didn't have a negative or I like didn't press enter. I mess up all the time entering. Just be super careful. So now I'm going to go matrix A to the negative first times matrix B. And I get out 1, -2, 2. Oh, those are nice, pretty answers. What that means is if I went back up to the beginning, I could fill in my matrix by saying this was 1 over x plus -2 over x minus 1 plus 2 over x minus 2 squared, and that should equal my original matrices. All right. Anybody questions on this type of problem? Again, I think A is a way more reasonable choice if I were to put it on a quiz or a test or anything, but I want to go over a harder one so it seems easier later on. Anybody questions at all? Thoughts, comments? Okay, we're going to go backwards to number 1 first, and then we're going to go back down to number 3. So scroll back up or turn your paper over and go back to number 1 on 7-4. We did skip that. It is pretty simple mathematically, but it's a very like special formula, special way of doing it. So I wanted to make sure I truly understood before I presented it to you. Okay, I do not need my calculator though. All right, find the area of a triangle with vertices 1, -1, 3, 2, -1, 7. If we were just solving normally, to find the area of a triangle, you need to do 1/2 base times height, which means we're going to have to do distance formula, and that is not fun. Midpoints, all that crazy stuff. So instead, I'm going to teach you a way to use our matrices, and we're going to start by graphing this out. So I'm going to graph it like legit. I'm going to try, it's a sketch, but I'm going to try my best. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. All right, good enough. Again, sketch, but I do want to kind of visualize what I see. I'm going to graph my points. 1, -1 is where A is. 3, 2 is where B is. And then -1, 7 is where C is. It's such a terrible job, but that's okay. All right, so make sure you have your triangle drawn out. Make sure you have it labeled. Okay. Once your page looks like mine, we're going to make a matrix because we're in the matrix unit. Our matrix, though, is going to come from something that we haven't really talked about before, but it's going to be easy to find. I'm going to do something called a direction vector. I just wrote AB with like a half of an arrow over it, kind of like a weird check mark. We skipped chapter 6, which was all about vectors and polar coordinates and all that fun stuff, which I know you're very sad about. You don't really need to know a lot of it. Vectors are a part of matrices, but I think matrices are way more useful than vectors, which is why we cut vectors and not matrices. What, though, I can use with my direction vector is I'm going to think about the change in my x. I don't know if you guys have seen delta x before. That's change in, that's physics. Change in x and change in y. So I'm thinking about, okay, I'm starting at A and I'm going to B. So like, how did I move left or right? How many did I move to go from like the X point for A and to B? And then I'm going to do the Y, same thing. So for A to B, I went from 1 to 3. So if I'm thinking like number line wise, I went over 2 units. I went from 1 to 3, 1, 2 units. So my first X is going to be 2. Then I went from -1 up to 2. -1, 0, 1, 2. That's 3 jumps. So my change in Y is a +3. So I went right 2 and up 3 to go from point A to point B. Anybody have any questions or concerns with that? We're going to do the same thing now with our direction vector from A to C. So pick one point and do the direction from that 1 point to both of the other points, and that will help us find this area. So now I'm going from A to C. A's x was 1, and then C's x is -1. So I'm going left 2 units, and I represent that I went left by saying I moved -2 units to show that I went to the left. My y value is at -1 for A, and it's at 7 for C. So that means I need to go up the distance between -1 to 7, which is 8 units, to get to C. Anybody have any questions on how I got those numbers? My distance from A, B, and then AC, my direction vectors? Okay, now I'm going to take this and make it into a matrix. So this becomes a matrix. The first row is 2, 3. The second row is -2, 8. This matrix I'm going to use to find the determinant of, and that's going to help me with my area. Remember, determinant is A times D minus B times C. So I'm going to do 2 times 8 minus -2 times 3. So I get 16 minus -6. And that becomes 22. I'm not done yet, but I'm almost there. I'm not done yet, but I'm almost there. Okay, so this is the determinant of my direction vectors. And to find the area of a triangle, we're going to do 1/2 of the determinant of my direction vectors AB and AC. So I just found my determinant. So my area is just 1/2 of that determinant. My area is 11. I'm going to put units on it, units squared, because I like to be exact with everything. Now, we could have found distance formula, done height, base, all of that fun stuff. This would be really hard with a shape like this. So what we do instead is we can use this cool matrix little trick, do the determinant of the direction vectors and multiply that by 1/2, and that is my area. All right. I do not have another one like this on my notes, but I do have one on the homework. So make sure that you try the one on the homework and use this problem to help you. Anybody have any questions yet?
Miss White, what'd you write after area?
I wrote area of a triangle.
Oh, that says of.
And then it's Yep, good question, Al. Anybody else questions on this problem? All right, we're going to move to number 3. So now scroll past 1, scroll past 2, go all the way to number 3. This next part is actually not matrix stuff, it's fractions, and it's a review of what we did back in chapter 1 or 2, I think, where we were graphing rational functions. So we're just going to practice graphing rational functions again. So I've got 3 examples here. What I want to do first is remind us how to find these things. So I'm actually going to kind of use this like blank space right here and go over the 4 things we need. In order to graph a rational function, we need asymptote. So I need vertical asymptote and horizontal asymptote. And then we need intercepts, x-intercept and y-intercept. Again, we learned this already. You learned this in Algebra 2 even. Like this should be old hat, but I'm just reminding you how to find these things, and then we'll do an example. When you find vertical angle, vertical asymptote, you have to set the denominator equal to 0. So to find the vertical asymptote, set the denominator equal to 0, whatever that is where we have our vertical dashed lines through your graph. Horizontal asymptote is you need to look at the exponents, and if exponents are the same, if they're equal, then it's a fraction of the coefficients. So horizontal asymptote, look to see if the exponents are equal to each other, then we look at the coefficients. What happens there, all 3 of these examples, this is the case. There are other special cases, but we're not going to go into that today and probably not on your homework. X-intercept, you set your numerator equal to 0 because anything 0 divided by anything is always 0. So set your numerator equal to 0. That will give you your x-intercept. And then your y-intercept is the fraction of the constants. A constant is the term without the variable, so it's whatever like the 2 numbers at the end are. It's the fraction of those 2. All right. Again, I'll have this up here and we'll refer back to it, but if you don't have this written down, I would do that. I think I'm going to do that. There's one other thing that we'll talk about, but that is not relevant for the first 2 examples. So let's come up here. We're going to do vertical asymptote. We're going to find horizontal asymptote. We're going to find x-intercept. We're going to find y-intercept. Some of this you can do in your head. I'm just going to scratch work it off to the side. Since this is not the first time you've learned this, I'm not going to be super like careful with my work, but you are welcome to be a little bit more careful than I am going to be. For my vertical asymptote, we set that equal to 0. So x squared minus 9 equals 0 is the same thing as x squared equals 9. And then we square root both sides. So my vertical asymptote is positive or negative 3. So I'm going to graph positive 3. I'm going to graph negative 3. My horizontal asymptote comes from the coefficient. So my exponents are both squared, squared on top, squared on bottom. So I'm going to look at whatever is in front of them. There's nothing physically written there, so we assume it's a 1. So my horizontal asymptote is 1. So I'm going to do my dotted line through 1. My x-intercept is where my numerator equals 0. So I'm going to say x squared minus 4 equals 0. Well, again, move your 4 to the other side. So I've got x squared equals 4, and then square root both sides. Just like the vertical asymptote, I've got two x-intercepts. I've got x equals plus or minus 2 this time. And then my y-intercept is now my constant, so it's the 4 and the 9. Pretend like the x's don't exist, pretend like they're gone. And so I'm like, okay, negative 4 divided by negative 9. I can simplify that to just be 4 over 9. I didn't graph my intercepts yet, so let me graph those. So I've got positive 2 and negative 2. And then 4/9, I'm not going to get too crazy. I just need it somewhere between 0 and 1. So that's somewhere in here. And I've got 3 little points right there, so I'm going to connect them. It's going to look like a little downward facing parabola in this like middle column. I know it's been a while since we've done rational functions, but whenever you have these asymptotes, the graph is always like checkerboard, where it's like kind of catty corner from each other. So like you'll never have like two graphs next to each other or one on top of each other. They're going to be like opposite each other. So if I have this graph in the middle, I'm going to also have one in the top left and in the top right. And this is what they normally look like. They look like little C's or little crescents. That's what they're going to look like up here. And you don't need any exact points, just kind of sketch it out for me. Kind of sketch it out. All right, and that's it. Anybody have any questions on that one? Okay. I want to do letter C before we go to letter B. So take a second, scroll down to letter C. I'm going to leave this up for a second if anyone's still looking, and then I'll join you on letter C. Take a second right here, though. All right, I'm going to join you on letter C. Again, I got to find VA, HA, x-intercept, y-intercept. Vertical asymptote, I set the denominator equal to 0, minus 1 divided by 8 is negative 1/8. Horizontal asymptote is just my coefficients, so it's 7 divided by 8. Got some funky fractions going on here. My x-intercept is where you set the numerator equal to 0. So 7x minus 2 equals 0. Add 2, divide by 7. I get 2/7 is my x-intercept. And then my y-intercept is where I just look at the constants, which is negative 2 divided by 1. And negative 2 divided by 1 is just negative 2. Now, at this point in your career, I'm not going to be super picky about x equals y equals, but I do those so I know like where they are. Do they go on the x-axis? Do they go on the y-axis? Are they horizontal? Are they vertical? As long as you can graph it correctly, great. But if you can't and you don't have your letters there, then we're going to have a conversation. All right. Okay. So I've got my asymptotes at -1/8 is my vertical asymptote. So almost on the y-axis. And then my horizontal is 7/8, so almost at 1, so somewhere in here. And then my x-intercept is almost, it's between 0 and 1, so it's in here somewhere. And then my y-intercept is -2. Okay, easy. I've got 2 little points there, so I've got a graph in the bottom left hand or bottom right hand quadrant. Got a little crescent that's, very close to the asymptotes. Try and make it a little bit curved and less jagged than mine, but it's a real tight fit. And again, it's checkerboard. They're across from each other, so its top left is going to have a little crescent shape too. All right, how are we doing so far? Everyone good? All right, we got one more, and we do have a special case on this one that we haven't had on the other two, and that comes right at the very beginning. So the special thing here is that I can simplify, I can factor both on top and bottom here and see if there's something that cancels out. So I'm going to do that. So I'm going to get on top, I've got x plus 5 and x plus 1. On bottom, oh, I'm gonna have to factor that twice. I'm gonna write it off to the side a little bit. I'm gonna take out a 2, and then I've got 2 times x squared minus x minus 2. Okay, I can see what multiplies be -2 and adds be -1. That's gonna be x minus 2 and then x plus 1. Yeah, I believe in that. Okay, we pause right here because I have a common factor. I've got a factor on top and on bottom. That x minus 1 is both on top and bottom, so they cancel each other out. From now on, I am exclusively looking at, except for one thing, I'm almost always just looking at these factors now to fill in the rest of my graph. What these canceled factors do, canceled factors, those make a hole in my graph. So we set that x minus or x plus 1, equal to 0, and that tells me where my hole is at. So -1 from both sides, x does not equal -1. There's a hole at x equals -1. So in addition to my VA and HA and x-intercept and y-intercept, we are going to have a hole which is at x equals -1. Some teachers make you plug that back in to this like new one to find out exactly where the hole is. I'm not going to make you do that, but I need you to graph all of it and like put this in context with the hole. That matters more to me. All right, so let's fill in the rest. Vertical asymptote is going to be +2, x equals 2. Horizontal asymptote is going to be 1/2. Yeah, I'm not really working this out. If you want me to, I would be happy to. Again, coefficients, 1/2. Set the denominator equal to 0. You can either divide 2 at the beginning or factor it or distribute it through, but either way, it will cancel it out and it'll just be +2 is my vertical asymptote. X-intercept is -5. And then y-intercept on this one, if you do it from the factored form, you need to make sure to multiply the 2 times the 2, or that's the one I do like to go back to the beginning and look at here because there's nothing that's been taken out of. If you don't do that, you're just going to make a smaller mistake. You'll think it's 5 over -2 instead of 5 over -4. That won't affect your graph too much, but depending on what those numbers are, it could make a big difference later on down the line. So I tend to go back to the very beginning for that. So again, my y-intercept, I look at the very first problem, and it's -5 over 4. Okay, let's get to graphing. Got vertical asymptotes at 2. I've got a horizontal asymptote at 1/2. I've got x-intercept at -5. And I've got a y-intercept at -5/4, which is between -1 and -2, somewhere in here. All right, I've got my little points here and here. I've got my asymptotes. So these two are in the same little quadrant of my new graph, and I'm going to connect them and, hug the asymptotes as much as I can. So I've got my little crescent in the bottom, and then I'd have a little crescent up here, catty corner, opposite, top right from it. All right, so we did some matrices on numbers 1 and 2, but number 3 was really a review of the past of graphing rational functions. And we, as of right now, are officially done with chapter 7. Does anyone have any questions on what you see right now or anything from today? So again, I think I mentioned this at the beginning of class, but I'm going to repeat it. 7.5 homework is due today, so I need it turned in as soon as you can. If you don't turn it in by the end of tonight, it's going to be late. And then I'm going to make 7.4 due on Thursday, which is the next time I see you, and which is 2 class periods, which is what I've done 2 days, which is what I've done all year. We are going to move into chapter 9 notes next time I see you, so make sure you have those. I'll put them online for anyone who wants to do them online. And again, we won't test on chapter 7 until Tuesday of next week. So we'll talk more tomorrow, Thursday and Friday, and we'll test on Tuesday. So if you have any questions, feel free to let me know. If not, I'm going to stop my share. I'm going to stop my video, and it's time for